All right, this is AP, AB, and BC Calculus. We are doing Unit 7, Section 7, which is finding particular solutions using initial conditions and separation of variables. So we're solving diffie-q's. Let's go ahead and get started. So in the last video, in 7.6, we learned how to find the general solution to a separable differential equation. These solutions involved c, the constant of integration. So to find the particular solution, we just need to use a given value to find the numerical value of c in a particular problem. Once we have c, we rewrite our general equation with the number in place of c to give the particular solution. So let's go ahead and do a bunch of examples. So we're going to find the particular solution, y equals f of x. Remember that this is code for, hey, you have to solve for y, right? So this is code for, hey, when you're done finding your general solution, solve it for y, right? And we're going to find the value of c in our general solution when we plug in -1, 8, and then that'll be able to give us our particular solution. So let's go ahead and separate our variables to start. So I'm going to multiply the dx over. I'm going to get dy equals, I'm going to rewrite this as a 5x to the -2nd dx, and I'm going to do the antiderivative of both sides. So I'm going to get y equals, I'm going to raise the power by 1 and divide by the new power plus c. So I'm pretty sure I get y equals a -5 over x plus c. So that's my general solution, okay? I'm then going to use the point I'm given, which is -1, 8, to find c. So 8 equals -5 over -1 plus c. 8 equals 5 plus c, so it seems that 3 is my c. Once I know that, my final answer is going to be the same as my general solution, so y equals -5 over x, but instead of plus c, I'm going to write plus 3, and that's my final answer. All right, go ahead and give it a try in P1. Same idea, and you can go ahead and pause me if you don't want me to do it with you. So I'm going to multiply the dx over, so I'm going to get dy equals a 12x squared plus 4x times dx. I'm going to do the antiderivative of both sides. So when I integrate, I get y on the left-hand side, and over here I'm going to raise the power by 1, divide by the new power. So I'm going to get a 4x cubed plus a 2x squared plus c. So that's my general solution, right? I'm then going to use the point I was given, which is -2, 1. So 1 equals 4 times a -8 plus 2 times a 4 plus c. So 1 equals -32 plus 8 plus c. 1 equals -24 plus c. So 25 should be my c. So then my final answer is going to be y equals 4x cubed plus 2x squared plus 25. All right. Moving on. Okay, so same idea, right? We're going to find the particular solution. Again, notice that this is our code for solve for y, and it hasn't been an issue in the last two, but notice in the last two that's because on this side I only had dy, right? So it was very easy to solve for y. It was already solved for y. So here, let's separate our variables. I'll multiply the y over. I'll multiply the dx over. So I'm going to get y dy equals x squared dx, right? I'll find the antiderivative of both sides. This will be a y squared over 2 equals x cubed over 3 plus c. Now I should solve for y before I plug in. It's usually easier to do that. So what's going to happen, I'm going to start by multiplying the 2 over. So I'm going to get a 2/3 x cubed plus, and I'm going to write c sub 1 because remember that trick we saw in the last video that 2 times c is just some new c, right? 2 times an arbitrary constant is just a new constant. And then when I solve for y, and this is the part where this gets a little bit tricky, right? There are two possible issues here, right? I could either get a plus or minus for my answer, right? Because when you write a square root in a problem, there are two possible outcomes, right? So I could have a plus or minus in front of that square root. So what I'm going to do now, right, is I now need to use this point, right? So I'm now going to use the point 0, -5. Well, right away, that tells me some important information. That tells me that it's the negative answer, right? That tells me that the one I'm using is negative of the 2/3 x cubed plus c sub 1. And the reason I know that is because even roots have a positive output. So in order to get a -5 here, I have to be using the negative of this answer. So now when I go ahead and plug in, I'm going to get -5 equals negative square root of 2/3 times 0 plus c sub 1. So negative 5 is negative square root of c sub 1. I'm going to square both sides, right? And I'm going to get 25 equals c sub 1, right? So once I know that, my answer is y equals the negative square root of 2/3 x cubed plus 25. Now this is an AP problem that they actually really like asking because the trick of the minus, and most of us forget about this plus or minus, or if we're not paying attention, default to the positive. So that's kind of a clever trick question. All right, so for P2, you're going to do the same basic thing I did in E2. You can certainly pause me if you want to do it without me. All right, so I'm going to start by separating my variables. I'm going to divide that root y over, right? So dy over root y. And I'm going to multiply the dx over to get 6x times dx. So I'm going to rewrite this root y on the bottom as a y to the negative 1/2, right? Because we're going to use the power rule to integrate. And I'm going to integrate both sides. So when I up the power by 1 and divide by the new power, I'm going to get a y to the 1/2. And when I divide by 1/2, it's the same as multiplying by 2. On the other side, I up the power to 2 and divide by the new power, so I'm going to get a 3x squared plus c. So this is a 2 root y equals 3x squared plus c. So I have been in previous examples solving for y first before finding c. You can certainly do that here if you want. You also don't have to. It's sort of up to you. Here, and maybe it's just because I'm tired, it's been a long day with a lot of math, I'm just going to plug in first. I think it feels easier in this instance, and then I'm going to solve for y. So it's up to you, but I'm going to go ahead and plug in 1 comma 9 to find c. So 2 times root 9 equals 3 times 1 plus c, right? So I'm going to get 2 times 3 equals 3 plus c. 6 is 3 plus c, so c is apparently a 3, right? So I now know that it's 2 root y equals 3x squared plus 3, and now I just need to solve for y, right? So this is my particular solution, but I just need to solve for y. And again, you could have done this in the other ones as well. I usually default to preferring to solve for y first, but it really doesn't matter. So I'm going to go ahead and solve for y. When I divide everybody by 2, I'm going to get a 3x squared plus 3/2, right? Now, I do have to divide that 3 by 2. Sometimes when it's just a c, we cheat and we say, oh, c over 2 is just a different number c. And that's true, but it's not a c anymore. It's the number 3. And when you divide the number 3 by 2, oh, sorry, it's I forgot that too. When you divide the number 3 by 2, you have to have a 3/2, right? And then I'm going to square both sides to solve for y. So I'm just going to write the entire thing squared, right? And that's the easiest way to do this. I'm certain you could, if you want, FOIL everything out, but it seems like a terrible life choice. So that's my answer. All right. We're going to go ahead and do one more example and one more practice problem, and that'll be it for this video. So we're going to find the particular solution to this differential equation. So I need to move my x's and y's around. So the dx has to be on the top. So even though there's an x thing over here, it doesn't matter. It's going to have to move to the right-hand side. So this dx has to move over, which also means that this thing has to move too, and the y needs to switch. So I'm going to get a dy over y. And on the other side, I'm going to get dx over this root 1 minus x squared, right? So when I do my antiderivatives, this is in natural logs. This is the natural log of the absolute value of y. But this one, this is arc trig. This is the formula for the arc sine of x plus c. Now, you can solve for y now if you want, or you can or you can go ahead and find c first. It really doesn't matter which one you pick. It's a different, depending on which one you choose, you're going to get a slightly different answer, but it really doesn't matter which one you pick. So if you choose to solve for c now, right, if you choose to use this point right now, I'm going to get the natural log of e equals the arc sine of 0 plus c. Well, natural log of e is a 1, and the arc sine of 0 is a 0, right? Because if you picture, so right here, right, the sine of 0 is 0, and so and the arc sine of 0 is so essentially sine of 0 is 0, right? So the arc sine of this 0 is 0, right? So it's hard to see because they're all zeros, but those are the zeros there. Okay, so basically I get that c is 1. So once I know that, I get that the natural log of the absolute value of y equals the arc sine of x plus a 1, right? When I go to solve for y, I'm going to exponentiate both sides, right? And I'm going to get y equals the arc sine, so e to the arc sine, rather, of x plus a 1. Now, this is fine. If you had done it the other way where you solve for y first, right? And we'll walk through that in a sec. But the other way to write this answer is you could treat this, right? You could treat this as e to the arc sine of x times e to the first, and this could be your coefficient. So this could be an e times the e to the arc sine, where the e is the coefficient. Now, if you had chosen to do this the other way, just to show you what that would look like, let's say you had chosen to solve for y first, so either of these answers should be fine. If you'd solved for y first, you would have exponentiated and gotten that y equals e to the arc sine of x plus c, or if you rewrote it, you could have made it c sub 1 e to the arc sine of x, and you'll see that if you plug in, you'll end up getting those two answers, either of them, depending on which way you did it. So that's how we solve for y, and that's how we get our answer. All right, you go ahead and try this one again. We're going to go ahead and find the particular solution to this differential equation. And to be clear, in this particular one, it doesn't actually ask you to solve for y, so I didn't have to do that. I guess I could have just stopped right here. I could have stopped here if I wanted, because notice it didn't say solve for y, and I'm just tired and I missed it. So same thing here, I didn't ask you to solve for y. So you don't have to solve for y. So if I split this one up, I'm going to get dy over cosine squared of y equals a 4x dx. Right, we've already seen this trick before. This is a secant squared. Right, so that's actually not a horrible antiderivative. So this is going to be tangent of y equals 2x squared plus c. And again, I wasn't asked to solve for y, so I did a silly thing in the last one that I didn't have to do, right? So I want tangent of pi over 4 equals 2 times 9 plus c. Well, tangent of pi over 4, this is pi over 4 right here. The x and the y coordinates are the same, so the tangent of pi over 4 is a 1. So I get 1 equals 18 plus c, so negative 17 is my c. So my answer, because I wasn't asked to solve for y, is tangent of y equals 2x squared minus 17. And that's my answer. And again, on the last one, just to go back for a sec, I should have stopped right here. Right? I could have stopped just right there and said the natural log of the absolute value of y equals arc sine of x plus a 1, and that would have been legit because I wasn't asked to solve for y. All right? And that is 7-7.